I can't add and subtract unless they're the same index and the same base. So this has an index of 3, this has an index of 2. Done. I can't even do it right now. But sorry, actually I take that back. I will be able to do that. Because as it turns out, 27 has a perfect cubed root, which is -3, and 9 has a perfect square root of 3. And when I add those up, I get 0. All right, next one. The idea is I have a radical, and right now I can't do anything because this has a 2 and this has a 3. But what I want you guys to notice is that the 7s are the same. And if you just rewrite these as exponents, now they have the same base. And in the base rule from my pink book, if they have the same base, then I could either add the exponents or subtract the exponents, which is what we'll do. All right, so I'm going to take 1/2 minus 1/3. I'm going to get a common denominator, which is 6. I'm going to multiply this by 3 and this by 2. That's going to give me 3/6 minus 2/6, which is 1/6. So when I'm done, 1/6 isn't my answer, it's 7 to the 1/6. All right, here, let's go ahead and take care of these. So first of all, this is like the square root of 25, and this is like the cubed root of 27. And again, there are those certain numbers I expect you to know that have perfect square roots and cube roots. So this is 5, and then there's the 2 that was there. And the cubed root of 27 is 3. And now I can turn that into 10, take away 3, and get 7. All right, we had a problem like this in the warm-up. The idea is to see, there was a mistake. Could you find the mistake? So this is pretty much our index card, our note card. So first, there was a fraction under the radical, so they broke it up. Check, they did good there. Was anything perfect? No, there wasn't anything perfect. So what they should have done is, when they fixed this, they should have had another square root of 5 here, and they only did it once. So this is where I made my mistake. So to fix it, I need to use another square root of 5 and a square root of 5. So when I'm done, I get the square root of 15, I get the square root of 25, and then I get 5, and then this just comes along. Next one, 50. No fraction. Is there anything perfect? Yes, they did that. But what ended up happening is this is 5, and this stays the square root of 2. So right numbers, wrong spot. So our mistake was right here, going from here to here. Here, so first thing is this was a fraction. They broke it up. The next thing they should have done is to see, is this perfect? They didn't do that. So this becomes a 2 over the square root of 3. And now we're going to fix it. So I get 2 times the square root of 3 on top, square root of 9 on the bottom. And then the bottom is now perfect, and it's 3. All right, last problem. Let's see. So first, can I simplify this? No. So then they broke it down. That's good. But what they didn't check is any part of this perfect? So this 8, when they did this, they could have actually broken it down into here. Okay? And now the 4 is perfect, and I can make it 2 with the square root of 2 over the square root of 3. And now I'm going to fix number 3, which says no radical in the bottom. So another radical of 3 and another radical of 3. So the bottom becomes the square root of 9. Those I can multiply because they're both in square roots. And now the bottom becomes 3. All right, last problem. Your job is to find the perimeter and the area of a rectangle that has, these dimensions. So let's kind of back this up and just do a simpler problem. If I have a rectangle and this is 7 and this is 3, and I want you to find the perimeter, I want you to add these up. So 7 plus 7 and 3 plus 3, and you add them up. So, or I could do 7 and 3 is 10. Here's another 10, and the perimeter is 20. The area, what I would do is multiply them. So I would take 7 times 3 and I'd get 21. Well, that's all we're going to do here. Here we have a rectangle, and one has a length of this, and one has a length of this. So before we go into these, let's just check out these radicals and see if there's anything perfect about them. And 6 is there, it's not perfect, and there are no factors that are perfect. 24, however, when I look at my list, 4 and 6 pop up, and I can turn that 24 into this, and then it becomes this. So rather than having this as our width, we'll use 2 plus this. Okay? All right, so let's find the perimeter. The perimeter says I should add all 4 sides. And the opposite sides are equal. So I'm going to take this plus this plus this plus this. So here's the perimeter. I'm going to write those out. So here's one length, and I'm going to make it, and I'm going to add the opposite. Here's another one. Now here are my other lengths, 2 plus 2 square root of 6. And here's another one. So here's a length, here's a length, here's a width, here's a width. And now I'm just going to add the things that are alike. Very, very picky. So 3 plus 3 is 6. 6 plus 2 is 8. 8 plus 2 is 10. And now I'm going to add up all these square roots of 6. So this negative version can cancel out this. Well, let's do these first. So 2 square root of 6 and 2 square root of 6, that's 4 square root of 6 so far. I'm going to write that down. And then if we really want a number, we could put a 1 in here. So that's like -1 and -1. There's a -2 of them. And if I add those up, I get 2 of those square roots of 6. And I won't add these because they are not like terms. The last one, the area says I should multiply these. Just like I took 3 times 7, I'm going to multiply these. So I might run out of room. Let me grab a Post-it note just in case. Okay, so I need to take the length times the width. And again, I'm going to put a 1 in front of there. And we practice, a little bit with this, but you're just foiling, or distributing. 3 distributes to both of them. So I get 6. And these I'm going to, and actually I take that back. Let me back up. I wasn't looking at the right spot. I don't want to use the 24. Sorry, I want to use the newer version. I want to use this version. Okay. So now when I multiplied this, the 3 and the 2 are similar, so I can multiply those and get 6 square root of 6. Now this is going to multiply in, and I'll multiply the 2 with the -1 and get -2 of them. And then I'm going to multiply these, and I'll multiply the things that are similar. So -1 and 2 is -2. And square root of 6 and square root of 6 will be the square root of 36. So as it turns out, what are the like terms that we can combine? Well, here are like terms. They both have square roots of 6's. So here I have 6 of them. Here I have -2 of them. That gives me 4 of them. And then this, as it turns out, remember what the square root of 36 is? That's 6. And then these are multiplying, so I could actually make that -12. Okay, those are gone. We added them to get this. And then I could take that -12 and add the 6 and get -6.